In today's video, we're going to look at Eulerian trails and the circuits. Let's firstly start with revising trails and circuits. As we have learned before, trails are basically open walk. We cannot repeat edges, however, vertices are allowed to be repeated. Once you understand trails, then circuits are easy to understand. They're basically closed trails. For Eulerian trails and the circuits, we can only find them in a traversable graph, which means the graph must be connected. Now let's compare Eulerian trails and the circuits. Eulerian trails include every edge in a graph. Then an Eulerian circuit includes every edge in a graph as well. To find an Eulerian trail, the graph must have two odd degree vertices. However, for Eulerian circuit, all the vertices must have even degree. An Eulerian trail will start at one of the odd vertices and finish at the other. And for Eulerian circuit, we need to start and finish at the same vertex, but you can start at any vertex. One example for Eulerian trail. So in this connected graph, we have vertices A, B, C, D, E. We need to firstly check the degree of each vertex. For A, the degree is 3, B 2, C2, D2, and the E3. So as you can see, we have only two odd degree vertices and the rest of them are even. Then to find the Eulerian trail, you can either start at A or E. I'm going to start at A. So we can start from A to B, to E, to D, to C, to A, then finish at E. So that's the example of Eulerian trail. Then have a look Eulerian circuit. Again, in this connected graph, we have vertices A, B, C, D. Degree of vertex A 2, B 2, C2, D2 as well. Then all of them, they are even degree. So we can start at any. I'm going to start at A. I can start from A to B, to D, to C, then all the way back to A. So as you can see, for these two examples, we include all the edges in a graph. The only difference is we start and finish at different vertices for Eulerian trail, but for Eulerian circuit, we start and end at the same vertex. One thing you need to be aware of is, if a graph have more than two odd vertices, then it is not traversable, therefore we cannot find an Eulerian trail or a circuit. So let's have a look at this example here. If we look at the degree of each vertex, so we have more than two odd degree vertices. Therefore we can conclude it is not traversable, therefore we cannot find an Eulerian trail or a circuit. Right guys, that's pretty much for today. Next Friday, I will upload a new video on Hamiltonian paths and cycles. Now I'll see you next Friday. Hope you have enjoyed today's video.